Right. Hi, Duncan. Garrett, Brian, Andrew.
Hello, hello, hello. All right. Got a bunch of people coming in. I'm kind of curious where everyone is, if you want to put where you're from in the chat, where you're calling in from. I think we've got people from kind of all over. I'm in Oregon right now. Yeah, welcome to the Software and Hardware Engineering Climate Career Week event. We've got Boston, Virginia, UK, starting to get a little late for you guys. DC, Denver. Just letting a couple more people come in. Won't wait too long though. We'll get started pretty quick here. New York, amazing. So we've got a pretty small topic today, just software and hardware engineering for climate. I'm sure there'll be plenty of questions. If you, we'll do quick sort of introductions for everyone. We'll spend a lot of time in Q&A today. If as you have questions, use the Zoom Q&A box or chat. It's like down. So there's the chat box window, and then there's the Q&A one. It's down at the bottom of your Zoom screen. If you pop that open, you can put questions in there. You can vote on them. You can comment on them. Keenan, who's going to be helping moderate the session, is going to pick his favorite questions out at the end to all answer. I guess without that, or at this point, I'll just kind of hand it over to you guys.
All right.
Thank you. Yeah, Keenan,
Keenan.
maybe you should start first, and then we'll.
Sure. Hey, everybody. I think hopefully this is going to be pretty casual and fun. So welcome, and thanks for listening to us chat. Welcome. We're going to talk about software and hardware engineering, and I think kind of with the lens of most of us who are here on this call probably have some aspiration. Either you're currently working in climate and you're trying to figure out, maybe what your next step is, or perhaps you are aspiring to be working in climate soon and you're trying to figure out your path to get there. So hopefully this is kind of a nice roadmap and just discussion for you to get some creative juices flowing and learn a little bit about what that might be like from some of us who have done it. So yeah, my name's Keenan. I'm in Seattle, Washington. Somehow we ended up in this panel with everybody who's kind of in the Pacific Northwest of the US, just totally on accident. And my career has had kind of a meandering sort of journey. I started my professional career in the aerospace field, so not at all related to climate, working on rockets and satellites and all kinds of interesting things there, and doing really in the weeds kind of hardware engineering. So I think I sort of represent a lot of the hardware engineering focus on this panel today. And hopefully I can bring some of that perspective to the group. Sort of after that, I really wanted to work in climate, and that was kind of my pivot moment. And so I sort of pivoted into a small startup that was doing electric aviation, which I thought was really intersectional and nice for climate. I mean, that was a great jumping off point for me in terms of my career, for starting my career working exclusively in climate. And I've been really lucky to sort of stay there ever since. I've worked at a bunch of other startups since then, all in climate, doing everything from sort of undersea robotics to terrestrial solar, big battery storage projects, all kinds of interesting things. And yeah, I hope that I've got some knowledge about the topic to share today. So great to meet everyone.
Love it. Keenan, we got to talk a little bit before this, and I don't remember you mentioning the underwater robotics, and now I just want to hear more about that. We have something of a robotics background, so very intriguing.
Very cool.
Yeah, so I'm Jamie, this is Jason. We're actually a husband and wife team. We're very nearly the same person in terms of our career trajectories. We're both full stack software engineers. We've both been technical leads. We've both been kind of in and out of climate tech startups our whole careers. To the extent that we're different, I specialize a little bit more in kind of project and team management side of things, thinking about this bigger picture of stuff. Jason is a much better data wrangler, data science type person. And yeah, kind of a quick overview of our careers so far. So I did a brief stint at Microsoft, but after that, we both were at Energy Savvy, which was this very much, I would say, climate tech company. Is focused on energy efficiency for primarily residential homes. working with utility companies to manage these like retrofit programs. So for example, replace your old fridge with an Energy Star fridge, or better yet, replace your gas furnace with an electric heat pump central heater. After that, we both ended up at Osmo, which was this IoT water quality company, and again, focused on kind of this efficiency question, so trying to make aquaculture more efficient. I then went to Convoy, which again, with the efficiency, was trying to make essentially all of trucking, America first, but presumably ultimately internationally, more efficient using essentially more advanced software algorithms. And finally, and most recently, we decided we wanted to like explicitly join forces together, explicitly work on climate change, and we started our consulting company called Option Zero. And basically, we just do software engineering consulting, but we only work with climate tech startups. So we've had some really fun clients in the last couple of years working on that. I'd be happy to bring them into the conversation if that ends up making sense.
Yeah, I think
Anything to add?
that like pretty much covers it for me, and a few differences there in my path. Like I was at Energy Savvy first, and I was the one who was like, you know, you don't seem like you're having a great time at Microsoft.
No, I was very jealous.
But then we also missed our origin story of like one of the first major projects we worked on together was a robotic sailboat. So that has a lot of those like I was the one leading the software team, and Jamie was the electrical lead.
And the entire team lead.
Yeah, and the entire team lead. Yeah. But that's sort of like the beginning of like really strong collaboration between us, but also a lot of focus on software and where it touches hardware.
Yeah.
And I feel like that's going to be a really important theme of this conversation here, where like I feel like a lot of people are doing software off in the software world, and that's like there's a lot of brilliant people doing great work there. But I think climate would benefit if people were more able to at least reach into and interface with hardware more.
Yeah, I mean, ultimately, climate is a problem with the physical world. So at some point, you're going to need hardware, or you're going to need to interact with the world, and just moving bits around or like pixels on the screen isn't quite going to get us there. So I think this is a really interesting topic, this like intersection of software and hardware, and yeah, really looking forward to kind of hearing more about your hardware background, Keenan.
Yeah, the robotic sailboat project actually came full circle in a really interesting way in this last week with the I don't remember what it was, but we built like a 1 meter long sailboat powered by wind. But people are actually like having real cargo ships in the wild, not just the wild, like doing cargo routes that are assisted by wind, basically starting like in the last year or so. And so that's like one of these technologies that's on the cusp of maybe being a real impact on climate.
Yeah, that's so interesting, and I think it's so cool that when I think about climate technologies and engineering, exactly like you said, Jamie, we have to have a hardware component, right? But also, kind of at least in the US and probably globally, we've been through a few waves of sort of climate up and down cycles, right? And I think so I think one of the things that's really foundationally different about the current wave that we're in is sort of the soul of this wave is the software experience that comes along with the hardware. And so it's really difficult to kind of divorce the two of those things if you're looking at solving problems, which I think probably most of the people on the call are interested in, right? Like we're here to work on climate because we care about the problem, not sort of like the act of engineering or software or hardware primarily, which is so cool. And yeah, I think the ocean and sailing is probably one of the under explored avenues for innovation in the world. It's of course really difficult, like you probably know from your sailing boat experience, but it's a big deal. There's a big emission sector there in sort of shipping, and it is a very old and sort of ripe for innovation sector.
It's very early on the decarbonization curve.
Yeah, for sure. Okay, well, let's get into like what kind of, sort of unpacking what is the what's the deal between software and hardware engineering? And I think we kind of wanted to talk about, because we've all had some experiences kind of mixing from both. So perhaps we could share, each of our kind of takes on, okay, like what's the difference? Like what are some skills and things that you might need to know in each field? And yeah, just kind of how we all see the world and sort of the division, or like how you might decide what you study or are interested in each field.
Are you particularly talking about the difference between software and hardware, like what it's like to be a software engineer versus a
Yeah.
hardware engineer on hardware?
Yeah.
You want to take that, or should I?
You take a first shot.
Oh yeah, great. Yeah, so I think we alluded to this in our introductions. Like, we are absolutely not hardware experts, but we're very familiar with the space, and particularly familiar with the way that like software intersects with it, whether it's with IoT, like Internet of Things, embedded software, robotics, getting software to physically move things in the world. A lot of just like straight up sensing for climate, like weather sensors or whatever it is. So we're very familiar with that intersection. But I think from our perspective, there's a pretty big difference in being a software engineer versus a hardware engineer, which is that being a software engineer, if you know how to be a software engineer, that's basically enough to go have a huge impact anywhere. And this tide may be turning a little bit with the like flipping of the market for engineers, and it being fewer jobs, more engineers. But in general, it takes so long to become a proficient software engineer that any company is going to hire you for that first, and then any industry specific knowledge will come second. So for example, I joined Convoy, which is this logistics trucking efficiency company, and I knew absolutely nothing about the trucking or logistics industries. And it was very much expected. The like company basically did a course on trucking for software engineers who were joining it. And I think this plays out in climate tech as well, where it's like software engineers can have a huge impact at any company, and climate tech companies are included in that. And just knowing software is probably enough for you to have the skills that you need to go help out. Not an expert in hardware, but my perception is that it's not really like that for hardware. Like for hardware engineering, you need to have a specific skill set. You need to know, I don't know, how to build wind turbines or something. You need to know how to design cargo ships. It's like the expertise needed is much more specific. And so my impression is that it can be a little bit harder to break into it. But actually, I'm curious if that's your take.
Sure. Yeah. Yeah, I can definitely see that perspective. And I think if let's not make it binary, but if it's like a spectrum, right, of like how much sort of industry knowledge do you need to kind of be in hardware engineering versus software, it probably does skew way more on the hardware side.
Mm-hmm.
But I think if you kind of think about and look at how engineering teams get put together, it's like, let's pick wind turbine, for example. It's not like nobody went to school and they're like, I'm a wind turbine engineer. For the most part, those teams are built by its mechanical engineers, it's electrical engineers, it's maybe some like material science people. You got project managers, and yeah, there are like really deep sort of like industry specialists, and you can certainly orient your career that way. But I know tons of hardware engineers who are sort of deep, like I do structural analysis and I'm a mechanical engineer and that's what I do. And a lot of those skill sets I think are pretty transferable around in industries, which is great news. I think for everybody who's like, especially, I meet so many people, for example, who have worked in the oil and gas sector, which has this huge employer, right, globally, and tons of engineering talent. And most of those people are like, I don't want to work at this anymore, maybe. Like, what do I do with my career? And I think what they're finding is, for the most part, all of their skills kind of come over pretty nicely. Just because like such, a lot of the ways that we put together engineering teams is kind of the same. And it's just, we have a different set of sort of values and problems that we go after.
That's actually a much more hopeful message, really, than I was expecting. So that's really good to hear. I especially like that the translation from working on oil and gas to like, what building wind turbines, maybe. Like, what a glorious transition that would be.
Yeah,
for sure.
Yeah, I think it sounds like there's both generalist disciplines that are useful across many different like sub industries or industries. and as well as displaced for specialists. Like we definitely worked with some specialists in like
Mm.
energy modeling that are
Mhm.
like, there's definitely room for all these for niches and people who are really good at a particular thing and can really give you a leg up if you're working on that thing.
Yeah.
Um,
Yeah, I think like one awesome choice that we all get to make is like, do we want to be a specialist in like a problem or in sort of like a skill?
Mhm.
And you
cool.
kind of get to pick, right? Like so you could be a specialist and sort of orient your career like I'm gonna work on electric vehicles or I'm gonna work on
Mhm.
wind turbines or like whatever problem you kind of like care about deeply. And then your game is like, okay, how do I use the skills that I have, whether it's hardware or software engineering, to
Yeah.
like move myself deeper into that industry? Or you can say like, I want to work, I have a sense of kind of the industries that I want to work on, but I care most about sort of being an expert in these skills for this kind of like more broad theme. Um,
Mhm.
which is also totally fine. Like we kind of need both sets of people, I think.
Mhm.
Absolutely.
Mhm.
Yeah.
Yeah, when I think about our careers, I mean, honestly, we kind of had both of those. Like Jason, I would say, is definitely trending towards an expert in energy modeling with like utility scale data. But we're both generally quite good at building web applications,
And
which is
I didn't get into that because I was like really excited
Yeah.
to do that particular thing. It was more like I'm a generalist, and that is one. I think I'm already seeing a question come up a bunch in the chat of like, what are the through lines? What are the skills that particularly are useful in climate tech? And like
Mhm.
energy modeling is one that just keeps coming up because if you don't know whether you're saving 10% of a small thing or 90% of a big thing, or like if you don't have a picture of your entire budget of like what you're doing, uh, you can't focus yourself on the right work
Mhm.
at all.
But just as much the general skill of like building a full stack web app. I mean, if I think
Absolutely.
back to the
Yeah.
clients that we've worked with over the last 2 years, almost every single one of them, we've been building an MVP web app. Like it's just such a ubiquitous piece of the solution right now that any company, any organization doing anything is at some point probably going to have some data that they care about and a dashboard where they need to view it. And then there's a million variations on the theme of like how much you need to be able to
Mhm.
input the data or run algorithms on the data. But like this is a way that we fundamentally interact with the world these days. And so yeah, being able to build a web application, which is a very general skill set for a software engineer, could apply in most cases.
Yeah, when you stand back and look at the architecture, most of the time
Yeah.
it's like 95%, yep, that's like a web app.
Yeah.
And then 5% is like, yeah, this little
Yeah.
dongle that makes it like actually
Yeah.
amazing. But that's like the application right there.
Yeah.
The
Yeah.
other kind of application.
Yeah. And you still get deep into the weeds, like of the particular problem. Like literally before this call, I was on a very deep into the weeds conversation with one of our clients over exactly how to build the data model for their regenerative agriculture carbon credit marketplace app. And we were talking about like tillage styles and how you talk about management events versus management zones. It was like very deep in the weeds. But if I take a step back, fundamentally data, like web dashboard to view it, and the like detailed deep in the weeds knowledge is something that kind of can come from the client in that case.
Yeah. It sounds like maybe that's would you rephrase that as like, is that a good sort of general strategy for like moving into climate is trying to segment like, okay, what is actually deep specialist knowledge and like, as I'm thinking about my career, do I need to become the expert in that? Or can I use my skills in like web app, for example, and work with experts to sort of solve that? Is there some advice in there you might give people who are making the transition?
Yeah, I mean, I guess both are valid paths. Like becoming a specialist in an area that's particularly relevant to climate, yeah, helpful. But also, I think climate, as with basically all problems that we face nowadays, could benefit from just the enormous leverage that general software provides you by automating repetitive tasks or organizing how you think of your data.
Sure. Yeah, that makes sense. Yeah, it reminds me very much of like, when I think about what are those general skills, because you talked about, web app, like if you're a software engineer today, like you probably need to be able to build a basic sort of web application.
It helps, yeah.
You don't have to be the best at it, but like, you know, kind of have to know the structure. And I think in
Mhm.
hardware, there's very similar kinds of ideas. So like in electrical engineering, like being able to make a custom circuit board. So printed circuit board is kind of the web app equivalent, right? For an electrical engineer. It's like, it's the basic framework that most of your work is going to be embodied through. And there's all kinds of deep specialist knowledge about what that is and how it comes together. And you can be a beginner or an expert at the craft of doing that, but like probably gonna have to have some knowledge around what that looks like.
Like there are some applications where like high power electronics are important, so you need a whole different subdomain for that. There's some like applications where like noise management on your PCB matters.
Yeah, for sure. And like for mechanical engineering, you know, being able to like use mechanical CAD and like design something and like make a drawing of it. That's kind of like a web app equivalent. And do some basic like if you don't know how to do like a stress strain curve for a material, that's kind of like a web app, like mechanical engineering style thing that you kind of like, it's just, you're going to do it all day, every day, if you're working as a mechanical engineer. And I think a lot of these like skills are just great kind of skills to, for me, when I felt overwhelmed or confused about like what am I doing like towards climate, is to try to anchor down on like a specific like skill like that and say like, okay, well I know how to do this. Who can I find that like I think I can do that in a helpful way? And sort of like if you're not sure where the problems are that you want to be solving, like focus more on the skill and craft and say like, all right, like who needs a web app for climate, like, and go try to solve kind of that, which seems a lot more straightforward to me, I think.
Yeah, I like that. That's a really great summary of essentially what we've done with our business. It's like basically who needs web app for climate, and like we have other skills that would be relevant, but haven't necessarily come up in this particular work. Like a web app is one thing, but I would say IoT or just like embedded devices, like things that are explicitly existing at this intersection of software and hardware, would be the other like big category of software related skill that would be pretty relevant to like stamp out across different climate problems.
Yeah, cool. Well, just because we started,
bring it back one more time to like, that sounds a little bit too much like, yeah, you like web apps, just like build web apps. We've seen there are probably enough carbon calculators out there, as much as I've been tempted to build one many times. You gotta touch reality.
Sure, yeah, that makes sense. Well, what are you excited about when you think about what are those reality touching projects that maybe you all get to work on, or you're seeing your friends or colleagues kind of work on, or just reading in the news? Emerging technologies, trends. What are you excited about?
Such an exciting time.
So many things for that, yeah.
Yeah, I mean, in the last few years, the IRA has been a huge thing in the United States, where just billions of dollars are moving into places where they kind of need to be, and it's changing the shape of markets, and changing the shape of things. But even less visible, there's a ton of technologies that are emerging and in really exciting stages of like, oh, this could be real, or this could, or like we were saying with the cargo ship thing, like there's a real thing that's actually like on a real place, this first of a kind concept, like where the thing is actually happening, is actually there, it's actually proving itself, and like now maybe we move into a phase where we need to make 1 million of them, and there's like maybe competition around who has the better implementation of it, rather than just like who is even doing this.
To name a few specific things, I always think of this quote. I'm going to mangle the quote. It's just like the idea from Bill Gates's book, How to Avoid a Climate Disaster. And he says something in the beginning that's basically, to solve climate change, we need to do a few different things. But in the end, we also need a breakthrough in one of 3 technologies, which is energy storage, nuclear fission, or nuclear fusion. And so those, I think, fission and fusion, I personally have a hard time tracking, because it feels like every other week there's like breakthrough, nuclear fusion works now, or whatever, you know. Um, and we've talked to some folks who are experts in that, and they say, well, obviously it's not quite that cut and dry. But energy storage, I feel like I keep seeing really cool specific breakthroughs in energy storage where there's like new chemistries, or there's new, just like thinking outside the box energy storage solutions. Like, I mean, pumped hydro is one, or like compressed air underground. There's just like really fascinating attempts to solve that problem. So I always like seeing that and kind of keep an eye on it. And to kind of give context there, the reason that energy storage is so relevant is because we have all of these, clean energy, clean electricity generation mechanisms like solar and wind, but they have this intermittency problem where the power isn't always generated when it's needed. You like generate too much sometimes and not enough later. So energy storage paired with those clean energy generation technologies is how we actually convert to electrify everything.
Yeah,
so
I love energy storage as a topic and concept because it's awesome. Like you've got on one hand really creative, interesting solutions like you talked about, like the gravity battery, or one of my favorite companies in energy storage is this company in Italy called Energy Dome, and they do a compressed CO2 battery. So they compress and then decompress CO2 for like really long-term energy storage. But it's just it's such a cool, novel way to think about energy storage that's like, kind of like simple machine style math. And I think it's great. But then you also have just like people scaling up kind of the technologies that we already know how to do. So just like lithium ion batteries is kind of a very known quantity. And we're going to keep making them better, but we know how to do it now. And it's, the cost has dropped so radically, and we've kind of got like all the macroeconomic forces around us to say, let's go put a lot of batteries out there in the world, and you've got people kind of solving it that way on the scale side.
Yeah, it seems like with always there's these cool breakthrough technologies that would be like fundamentally new understandings of science or like completely new engineering undertakings, and we do need those to solve climate change. But then there's kind of the secondary thing of, like you said, scaling up technologies, and then maybe a tertiary or just like less sexy but equally important would be things like efficiency, energy efficiency, using less energy, using the energy that we use more, just like there's a whole lot of different industries where efficiency is part of the solution. And I think it's particularly relevant for software because software is like an enormous lever arm for making things more efficient. So if you're looking for opportunities and you're a software engineer, then like looking at the technologies that need to get more efficient and then like applying algorithms, applying AI, whatever it is a pretty good like rinse and repeat strategy.
Yeah. I'm talking about like Go ahead.
Oh no, I was gonna say, Jason, maybe if maybe do you have any examples of like how you've used software recently and sort of your engineering expertise to do something that you thought was pretty innovative? I know we talked a little bit before. You had a few examples, like Advantis as one that you kind of threw out.
Or maybe the Energy Raven work.
Yeah, Energy Raven was very interesting. It's not just we're working with one company that's in this area, but it's in really it feels like a really kind of maybe like a frothy environment where everybody knows that there's ways to accelerate residential decarbonization in the US, and everybody knows that there's like money flowing into it, and people want their homes to be green and they want them to be warm and they want to not spend as much on energy bills. And there's a tremendous opportunity in home decarbonization also, and just not just decarbonization, but like things like weather stripping, like home weatherization is a great fit for lots of like low income folks where you can have an equity angle on that too, where you're helping people who like aren't going to spend $10,000 on a heat pump by sealing their windows and doors, because that's actually like can be a hugely cost effective solution. Energy Raven was particularly interestingly placed product where they're working with home inspectors who in the United States have a lot of knowledge about structural and like appliance issues in a home, but aren't energy auditors by any like definition. But they are present in almost every home sale in the United States. So most times when you sell a home, an inspector will come, they'll look at it, they'll collect some on the ground data about the home, and they'll tell you like, is your insulation, is your foundation, going to fall over? Do you need to worry about this or this other thing? And what Energy Raven is like an additional little like a sidekick that the inspector can bring with them to add energy related information to their inspection report. And so then when you're looking at buying a home, suddenly you not only know whether you're buying a big risk in terms of your foundation, but you also know if you're buying a big risk in terms of energy costs, and you know what your opportunities are in terms of like what would it look like to put a heat pump in this home. And it's a moment when people are spending like maybe hundreds of thousands of dollars and tens of thousands of dollars for big energy efficiency upgrades might actually be something that you can like, it's the right time to poke the potential homeowner about those things. So that was one exciting like little like nugget of like these things swirl together and you're like, okay, what if we just like brought some of this other thing in here, and maybe we can accelerate everything.
Yeah, cool.
That was one.
Yeah, I feel like that's a fun example because it's like that whole story is such a classic software startup. Like it could be this, in this case, it's not VC backed, but it sounds like the classic VC backed software startup that's like has a really specific niche problem area, and then they just need to build a software solution that addresses that niche. And in this case, it's this amazing confluence of also solving climate change as well. But you could tell that same story about something that had totally different players, but it would all kind of add up to the same plot. Like it's just software startup plot, finding product market fit, building your MVP app, and like the fact that it's climate related is almost incidental.
Yeah,
and that's a fun one.
And that is what
Yeah.
That's necessary for a lot of like consumer oriented climate solutions. That you don't have to be like, people don't have to be in it to save the planet.
Yeah.
And then things like the IRA bill, this is like just one of those places that it touches where like, oh, heat pumps are 30% cheaper now. Solar is 30% cheaper now. Like suddenly you might have a viable business where you didn't have one before.
Yeah. Cool.
Yeah.
Well, so interesting. I didn't really know about this Energy Raven thing, but is there a hardware component to that solution? Like, do they bring any sort of like devices out in the field, or is it sort of okay, cool?
Yeah, there's actually a really similar project by Rewiring America. This is another thing where like there's startups trying to do this, and then Rewiring America is a nonprofit that just moved into the space in force with some of their own offerings, and I think that's really cool to see. There's just like there's now lots of players in the ring, and
sure, yeah,
it's not a vacuum anymore.
Cool. Wow. Well, so time has gone by so fast. We're already at 35 minutes here, kind of in, and I know we have a ton of questions. So like, maybe it's more fun to just kind of get into the questions. But before we do that, just if there's any sort of final thoughts, Jaime or Jason, that you wanted to leave people on advice as they're kind of navigating their careers.
Ooh, that. Let's see if there's any questions about that. I feel like I have lots of opinions on that.
That's fine. Yeah.
One totally random thing that I want to throw out there, because I want everyone to like go Google right now, that we haven't talked about, is there's a lot of really cool innovation in geothermal energy right now. And it's like something that I basically hadn't heard anything about. And suddenly in the last year or two, I keep hearing about this like the super hot rock geothermal. There's just like that feels like a true potential, like essentially science/engineering breakthrough, where it's like, this is awesome. It's totally new technology. Yeah. And
it's exciting for a lot of reasons. One of them is the potential to bring oil and gas skills, because like you have to drill directly to get you're drilling down to find heat basically, instead of drilling down to find fossil fuels to pump into the atmosphere
to make heat. Just get the heat directly. Bypass the dead source.
And
for sure.
I think it was like last couple of months there was a Google sponsored project lots of money coming from cloud providers to do who have zero
to
carbon
meet there.
commitments. That's a great place to be looking both for geothermal and for energy storage. We didn't mention hot rock energy storage, but that's also a type of warm rocks, box of rocks. Where it's like a crazy simple technology. You heat up a bunch of rocks, like your carbon CO2 compression. Heat up a bunch of rocks and then pull out the energy when you need it.
Yeah, so that was like a bit of a right turn from what we were talking about before, but it's just
Back to
such a cool technology, and that's one that I hadn't heard of much, and now it seems like it's more of a thing. So I think that's super fun.
Yeah, cool.
Yeah, let's see.
Yeah, for sure. Yeah, like we said, this is pretty casual, just chatting. But I guess we would be remiss. The number one upvoted question right now, which is probably for you all, but what are the main tech stacks that you're seeing kind of in climate tech today?
Wow, that feels like a softball for like
yeah, we'll start it off easy here. Hopefully that's an easy one.
So we teach a course with TerraDo called Software Stacks in Climate Tech. And so the course will basically answer that question, except spoiler, we don't say that it's not like what you would traditionally think of a software stack. It's not like every climate tech company is using a Node backend and a TypeScript React front end. It's the way that we talk about software stacks is more about these like areas of software engineering that are particularly relevant to climate. So the ones we talk about are public data sets or large data sets that you can get access to. Energy modeling, partially because that is our background and also because it's very relevant to climate tech. And then this software hardware interface. So in the course, we do like a fun with IoT segment essentially. So those are the ones that we teach in the course. I do think that there's not like a software stack that every climate tech company uses. There's just things that are more or less relevant.
Yeah, that's the thing, is that the generalized software like web app technology has been on the move for the last couple decades and has reinvented itself several times, and it just keeps getting mostly better and better, sometimes a little worse. And so if you talk to any particular company or organization, their front end, back end, like in the traditional sense of a software tech stack, will have to do with the people that they had on at the time and the tools that were available at the time. And there will always be some amount of legacy. And some people are very happily still using PHP for a lot of their applications, even new ones, because that might be what meets their team and their needs right now. Might just be where they find it.
Yeah, it makes a ton of sense. I like the way that you kind of reframed the question a little bit, which is probably not what they were asking, but like blowing it out a little bit bigger and saying
go back to that.
Well, no, I think this is a totally more interesting train of thought of like, what is the sort of like application stack that you're thinking of? And that's like kind of a more interesting question, because kind of like you said, it, as long as like your software tech stack is good enough, it's probably fine. Like for whatever you're doing.
It ends up, it's like I was describing before, where you have like a 95% generalist stack, but the 5%, it still is part of your stack that interfaces with the climate world, or that does the climate thing. 5% might not be right, but yeah, you have some sort of like, it's usually some sort of energy modeling thing, or some sort of interface with a data set that's climate related, or an interface with something hardware related.
Our energy raven example from before is exactly that. Like it's 90% a regular web app, and then there's the energy modeling piece of it that's interacting with some public data sets and interacting with Open Studio, which is this government sponsored energy modeling tool. So there are climate specific pieces of it that are relevant.
And so when you say stack and you're expecting us to say like Django or Ruby on Rails, that's fine. But you're wrong. And where it interacts with climate is actually, we consider that to be also part of the stack and worthy of focusing on its own.
Or maybe they're actually trying to ask, and we just misinterpreted their question.
You're not wrong.
No, that's a great answer. I love that. Okay, so kind of moving on to the next question, because I think we hit that, and I don't have a whole lot to add on the tech stack there. But so Keith asked, they are unemployed currently, and they're trying to figure out how to differentiate themselves in the job market. So do we have any advice for how Keith can make themselves stand out? So kind of their answers are should I get certificates? Should I do like advanced training? Like what? So I don't know if the two of you have any thoughts there.
It depends a little bit on what Keith's background is, but I'll answer it as though they're a software engineer with like, let's say my background.
Yeah.
It's very easy.
Okay, that's great. I'll answer with the hardware perspective then
Okay,
after
great.
you.
Yeah, great. My opinion, and it's a fairly strong opinion, but it is just my opinion, is that being a good software engineer is the biggest thing that you need to do to get hired as a software engineer at any company. And in fact, I think that interviewing and getting hired as a software engineer is kind of its own skill set. Keenan, I'm not sure if this is something that you've experienced in your career, but like, especially these days, if you want to get hired at like Meta or Google or whatever, you basically need to spend like months maybe just brushing up on the like exact type of interviews that you will do. There's like these algorithms interviews, these software architecture or design interviews. They're like kind of specific. It's kind of its own beast. And so at most companies, getting hired as a software engineer is very different than being a software engineer at the company. And that is less true or less universally true at like smaller startups, which maybe many climate tech companies are. And in that case, it might be more about your network that gets you like in the door to the first like in-person interview. But that being said, I think the things that can come through once you're in the door and it's like you've proven that you're a good enough software engineer, the thing that might get you specifically hired could be your passion on the topic and your like familiarity with the topic, or even just your momentum in that direction. So it certainly wouldn't hurt to take something like Terradu's Learning for Action course, which gives you like the full baseline understanding of climate change, or if you're specifically a software engineer, taking our course and then getting this like really specific momentum on dipping your toes into the climate space, and also just meeting other people who care about the same topics. That wouldn't hurt. But if you were only going to do one thing, I would say you need to go ace your software interviews. So you probably need to do like 100 lead code problems.
Yes, folks have been mentioning the lead code grind in the chat.
The lead code grind, yeah, that's the real thing.
Yeah, that pretty much covers it.
Yeah, sure.
I'll drop an article about my software job search. That was basically, I did a lot of lead code problems.
Cool. Yeah, and my experience is definitely, I think, where it's intersectional is like if you're looking at smaller companies, it tends to be less rigorous on sort of the engineering interview process, right? So smaller companies are usually more flexible, and you can sort of win somebody over maybe with your passion or interest in a topic, or maybe relationship. Also, I think having a portfolio, if you can, of just like, here's some projects that I did that sort of say like, hey, like kind of like prove it. Like they don't have to be like, exceptional or super deep, but something that shows, it's a tangible anchoring point where the people on the other side can ask you questions about it and try to start to explore like, is this the style of human and an engineer that I want on my team? Is great. And I think, if you were like to think about what the experience of being most hardware engineers at sort of bigger companies, there's not really like a leak code equivalent for like a mechanical engineer or electrical engineer, right? Because in one sense, those industries are so much older than software engineering. We kind of have like established best practices. So I think that what you might find as you look at bigger companies for those kinds of roles is they're going to kind of ask you more like kind of textbook kind of questions. So like mechanical engineering, like draw me the stress and strain curve for like a random steel. Like that's like kind of a, that's probably something if you took a mechanical engineering course, you probably learned it in your materials class, and they're not looking for like a perfect answer, but they want you to have the general sense of like, what does this look like, kind of thing. Um, Electrical engineering is very much the same. It's like, show me how to like do a voltage divider with some resistors. That's like a really classic, like kind of basic thing. And just like, the reason software engineers are asking you leak code and those things are related to your maybe job, but kind of different, is it's just sort of everyone knows it's not perfect, but it's an indicator of like, has this person developed some like interest in the craft and the skills where like they're kind of like motivated and have some knowledge there. And so like in on one sense, it's kind of just like your homework becomes relevant again as you look at the EE and like hardware kinds of jobs.
Hey, Keenan. Hi, Sudha here from just a couple of, I think it's a good time. There are a couple of themes that are emerging with this. So if there's any opportunity to comment on the impact of AI, on how you think it's going to impact on engineering skills, as well as what are some of the skill gaps as an engineer when you have to learn for sustainability and design. Is there anything that you can specifically advise? So I'm just going to pop that in because it feels like a good time to theme that in.
Yeah.
Well, Jason and Jamie, you want to take this AI one? Because I think this is closer to your world than mine, probably.
Dangerously close to our world. We're not going to have jobs in 10 years. No, I don't know. Jason keeps up on it more than I do.
But the short answer is we don't know. Like we are actually really not experts and haven't worked on any AI specific projects.
That's not true. We built the deep learning algorithm for IoT. Not deeply though. Yeah, no, we're not the latest experts for sure.
But yeah, it's changing everything. Keep an eye out.
Yeah.
It makes me a better coder. It makes me faster when I use the right tools at the right time, whether they're AI tools or not. I think another thing that is sort of in a similar vein is maybe transforming the software industry a little bit is low code and no code options that are getting like where they used until recently. I think they're mostly like pretty toy-like things, or like AIs took a lot of effort to make value out of, but now there's things that are like off the shelf that you can like imagine turning much more quickly into a business. So yeah, it's important, but I don't know. Yeah, Matt, retool. Yeah, bubble.
I think what's fascinating about the AI discourse is that when I look at the discourse, so in software engineering, like I'm closer to hardware, right? So software engineering for embedded systems like microcontrollers and things used to be much closer to like the electrical engineering job. It was like a very, like you had to be very deep down in the microcontroller and you're writing a lot of assembly. And I can go pull news articles from 30 years ago that read almost identical when like the C compiler was introduced. And people were like, oh my gosh, we're not going to have to write assembly anymore because there's this new thing, like it's going to take all our jobs. And I know that they're not the same technology, but sort of like the general theme of it, it's an accelerant for like how you can create engineering progress. And it's clear now that we know the compiler, the C compiler did not take jobs, it created them. Certainly, like in terms of macro like scope, like people had to maybe sort of shift their skills a little bit, but yeah, it was not a job eliminator.
That's actually made a connection in my mind that I hadn't quite made before. But basically, this stepping up of higher and higher order languages, higher and higher level languages, like that's definitely a thing in programming. Yeah, there's like assembly, there's like zeros and ones, there's assembly, there's the C, there's the C compiler, there's Python, there's TypeScript, there's all the 1,000,001 front end frameworks. And kind of what they do is just let you more efficiently translate your requirements into code. But as a senior software engineer, like as a relatively senior software engineer, I find that more and more of my job is defining those requirements. Like we're building a web app for a client right now, and we have barely written any code because so much of our time is getting really crisp about the problem that we need to solve, the shape of the solution, what requirements are important, and then translating that into the general architecture. And once we have the architecture, writing the code is not the hard part, like especially not the like physical typing out of the code. And like making that a little bit faster using AI tools, or if we can get an even higher order AI that can just like, I don't know, you tell it exactly what you want and it builds it, that still won't cut out the first half of the problem, which is like defining the problem and defining the solution that you want. And maybe it's just making software engineering a more and more pure form of engineering, which is fundamentally, I think, about defining the problem and then like enumerating solution options and then picking a solution option. So that part of engineering maybe will still exist, even if you have AIs that can take, your like text prompt and build you a web app from it.
You see demos of those and they like kind of do what you tell them to, but
yeah,
not really there yet.
Yeah, cool.
It's just,
I
it's
love
like
that perspective.
Yeah, and you're seeing the same thing with AI for writing. Like we have a professional writer friend who produces higher quality stuff than you get directly out of ChatGPT, but who might use it as a thing to accelerate them. Same thing
Write
with
the first draft.
Same thing with artists. Like
Mhm.
they might spend the skill of drawing particular things might be not as valuable, but the right type of high level artistic thinking is still going to be crazy valuable.
Mhm.
I also think what's interesting when I put on my hardware hat, right, is kind of the name of the game in climate is energy. Like where does the energy come from?
Mhm.
And that's sort of a big question mark that everyone has
Yeah.
in the AI scene is like where does the energy come from? And so we may see sort of like a rebalancing of like how we think about like really large scale compute and moving that more into like really low power kinds of situations where it's it's going to be a budget kind of thing that everybody has to solve. Like I got to balance my energy budget, got to balance my like fiscal budget, and that's going to be a part of everyone's job if you're working in engineering very soon, which I think is quite interesting.
Yeah, that's like the geothermal project in Nevada that Google just funded.
Yeah.
Balancing the energy budget,
That's
balancing their carbon budget.
Exactly what they're doing.
Yeah.
No, that just they're doing
just
it for
energy.
zero carbon energy, not just for carbon neutral.
Is there, sorry, I've just been monitoring the Q&A, so I hope you don't mind me just stepping in.
No, please.
Throwing questions at you right now. So I think there's also some interest around, as we're on the theme of skills, I think there's some interest around like, I think a contrast between entry-level engineers as well as those who have quite a number of experience, like 20 years experience. Like what sort of recommendations do you have? I think there's some energy around like, do I need to specifically retrain? Do I need to like how important is like there's a lot of listings for firmware engineers, like how, as a generalist, how do I need to really relearn this? And I think maybe getting an idea of like, what is the divide between generalists and specialists in this area?
Well, I can definitely share my thoughts, which is one, having been a hiring manager hired a lot of people, most job postings are terrible. They were written in between like bites of a sandwich and you like half thought through it. And everyone knows that like what's on that page in the job posting is like, it's like if you squinted and kind of like step back, like maybe it's close and you think it's something similar, but it's not a literal definition of what you think the universe is like for the perfect human. And I think a lot of people's strategy when they write those job postings is they just throw a bunch of stuff out there and they're like, I hope someone shows up who can check like 3 of these boxes, like maybe, and you don't really care like which 3 the boxes they can check. And so I think that's just really helpful, like just to remember that. I know it's hard when you're in the job seeking position because it's very stressful. And if you've got like a timeline associated with when I need to find my new job, of course, that is challenging to think about. But, just try to look for like, no matter what kind of job you're trying to go, like what skills do I have that I think I can like slot into some portion of this? And how can I just explain that and then show genuine interest in sort of what problem they're kind of solving at the job company. And I think get creative about that. And if you're thinking about it that way, I think the question of like, am I, in the beginning of my career or sort of later stage becomes less important, because you're really anchoring on like, what can I bring to this job now? And, look for where you think you have transferable knowledge already, and then areas that you're excited to grow into. And I think every hiring manager on the planet is more excited to pick the person who's excitable and sort of on the growth path, I think. Versus like somebody who's just like, whatever, I don't care, I'm the best at like building antennas, and like, you need an antenna, I'll build it for you. Like versus like,
that's really literally Jamie's dad.
Okay, sorry, I didn't mean to
No, it's great. It's a black magic, and specifically if you need an antenna built, you want basically an antenna engineer with like 20 years of experience. So that actually does work for him, and I think that's unique.
Yeah, totally. And there's always going to be that archetype, but most people are also excited for like, hey, like I've got 5 years, basic EE experience. I'm really excited to do this thing. I want to go on this journey with you. And I think that message is pretty compelling for most hiring managers.
Yeah. Bring the growth mindset.
Yeah.
Don't forget what you like, know what your skills are. But mostly bring the growth mindset. Those two things together.
All right, I think that about wraps it up. If you guys have any like super final quick thoughts, but I need to start opening up the chat for the next session as well. So thank you all for coming to the session. Super informative, super great. Hope that helped everyone. Here's a quick look at tomorrow's events. Also relevant if you're trying to look for a job in climate. We have some stuff with career coaches and about impact. So specifically diving into which solutions have the largest climate impact. If you happen to be an engineer but also work in marketing, we have a marketing event, another in climate marketing event, another in climate event, just like this one, right after, as well as carbon accounting, product management. And if you're in LA tonight, then there's a mixer in person for you to go to. Otherwise, yeah, we'll see you guys at tomorrow's events. Thank you, Jamie, Jason, Keenan, and our community ambassador, everyone for coming today, and see y'all tomorrow.
Yeah, thanks for having us, Ian.